The first new property is the product of powers property, okay? Now, the most important part for this property to happen is that you are multiplying powers with the same base. Please highlight that phrase, same base. Now, do you guys remember what the base was in an exponent? In a power? Yeah. Is the number on the bottom, right? And then the little number in the top corner was called what? Exponent. The exponent. So as long as the base is the same, look what we can do. When two powers are being multiplied and they have the same base, what are they doing with the exponents? They're adding them, okay? So anytime you have the same base, you're multiplying those two together, you're getting a product, you can add the exponents together. Let's see why this works. I want you guys to be very proficient at this. So I would like you to take 2 to the second and multiply it. Do this over on the left-hand side and multiply it by 2 to the third. Let's think about it. So what is 2 to the second power? 2 times 2. So let's break it down. Let's break it down to 2 times 2. Let's not make it 4 yet, okay? Now, we're taking 2 times 2 and we're multiplying it by 2 to the third, correct? What's 2 to the third power? 2 times 2 times 2, right? What is this the same as? Peter? 2 to the power of 5. So go back to the beginning. What did we do with the 2 and the 3?
Added it.
You added them together. Okay? So this is proven for you why this works. But it only works if our base is the same. So don't use it if it's like, and write this down as a counterexample. If we have 3 to the second power times 2 to the third power, can I now add these exponents together? Absolutely not. Okay? This is a bad example because my bases are different. Okay? Peter, what's up?
What if the 3 was negative when you subtracted?
You're so good, okay? We're going to get there in 1 second, okay? All right. Now, it also works. So watch. When we had a product, that means multiply, right? What did we do with the exponents? We added them. When we're dividing and we get a quotient, what do you think we do with the exponents? Very good. You subtract them. So circle the word subtract. And again, highlight the fact, what kind of base do we need? The same base in this example as well, okay? And then take a look at the example that they gave. They gave 4 to the 6th divided by 4 to the 3rd. So that would be 4 to the 6th minus 3, which is 4 to the 3rd, okay? I'm going to prove this one to you as well. So over on the side, let's do 3, let's do 3 to the, 7th over 3 to the 4th. Okay? What is 3 to the 7th? 3 times 3 times 3. How many times?
7.
So 7. So write all 7 out. I hope that's 7. Is that 7? Yes. Okay. And it's over how many 3's on the bottom? 4 of them. So 3 times 3 times 3 times 3. Now, I told you guys before, if you're multiplying and you have a common factor between the numerator and the denominator, what can you do with those common factors? You can cancel them out, right? So each of these 3's, as long as there's 1 in both the numerator and the denominator, will cancel out, correct? So we're canceling out, we're canceling out, we're canceling out until we have how many in the numerator? Now, what is 3 times 3 times 3? It's 3 to the 3rd power. So check this out. What's 7 minus 4? 3. Interesting, right? Now, this only works if you have what for the bases? The same base, okay? Some pretty cool stuff, okay? Now, the last one, okay? Josh, what's up? What if it's not a number, it's a variable? They still cancel out. That's a very good question, okay? So if it was x to the 7th over x to the 4th, you would still subtract the exponents, and you would get x to the 3rd power, okay? All right, now we have a power of a power property. So it says, let a be a real number, and let m and n be integers. To find a power of a power, you multiply the exponents. Now, this is a very specific scenario, okay? And usually it requires parentheses here, okay? So we had 4 to the 6th, and we're raising that to the 3rd power. So that gives us 4 to the 6th times 3, and 6 times 3 is? 18. So our new exponent became 18. Let me prove this one to you as well, okay? So we're going to do this one over on the right. I want you to write 3 to the 3rd power, and we're going to square it. Now, let's prove why this becomes 3 to the 6th, okay? What does it mean to square something? Multiply it by itself. And right now, we're squaring 3 to the 3rd, right? So do you guys agree that I could write this as 3 to the 3rd times 3 to the 3rd again, because we're squaring that? Because if you square something, you multiply it by itself, correct? And what were we squaring? 3 to the 3rd power. So if we square 3 to the 3rd, it's 3 to the 3rd times 3 to the 3rd. Do they have the same base? So what can we do with the exponents? What's 3 plus 3? So we get 3 to the 6th. But check it out. What's 3 times 2 from the beginning?
6.
3 to the 6th. Do you guys see that? Okay, so this is the power to the power property proven. Okay? Yes, Charlie.
Is that always gonna work though?
Always gonna work.
So that you can just multiply that inside, it'll be that.
Mm-hmm. What's up, Gage?
So for each situation, let's say we have negatives, like negative exponents, what do we do then?
So we're gonna see those in the case-by-case basis, but we treat them the exact same way. Okay? We don't treat them any differently. Did you guys hear Gage's question? He said, what happens if any of our exponents are negative? We don't treat them any differently, but when we end on an answer, are we allowed to have a negative exponent? No, so we're going to somehow have to change those exponents to be positive at the very end of our answer. But we don't care about them until the end, okay? All right, let's check it out. Let's check out example 3. We're going to do all of these examples. So start with letter A. 3 to the 2nd times 3 to the 6th. Does anyone have an idea of what we get here? 3 to the 8th power. You guys are all correct. How did you get 3 to the 8th? You added the 6 or the 2 and the 6, correct? Why are we able to add the 2 and the 6? They have the same base. Please, guys, even if you're very familiar with this, circle the fact that they have the same base. That is the most important part, okay? Because if they don't have the same base, we can't add their exponents. Very nice. We Gucci? Okay. Now, as a rule of thumb, if during our lesson, if the exponent is ever higher than 3, so 4 or above, we are not going to have to multiply it out. So I would not expect you to take 3 and multiply it by itself 8 times, okay? I'm not that mean, all right? Now, big ideas, just to give you guys fair warning, it does expect you to leave everything as a number, right? So it would expect you to multiply this out. You are allowed to use a calculator if the exponent is higher than what? 3. Anything cubed or squared, so to the 3rd power or to the 2nd power, I expect you to do it manually, okay? Because on the exam, I'm going to expect you to do it manually as well, and you need that practice, okay? Anything to the 4th power or above, though, you can just leave it as to the 4th power or above, okay? All right, B. We have -4 to the 2nd power divided by -4 to the 7th. What do you think I do here? Josh?
So first, what did you have to subtract? What did you subtract it by? Subtract 2 minus 7?
Very good. No, he's absolutely right. We subtract our exponents because what's the same? The base. The base is both? -4. So watch this. You rewrite the base, which was -4, and you do, what did Josh say? 2 minus 7. What is 2 minus 7? Gage? Not 5. -5. So we have -4 now to the -5th power. Gage, this is your negative exponent example. Guys, can we have a negative exponent in our answer? Absolutely not. So what do I need to do? Kevin? Very good. I need to make it into a fraction. And this part belongs in the denominator. Because if it's negative, it doesn't belong where it is. So we're going to write it. What's my final answer? Does anyone have an idea? Kevin, go for it. Yeah, buddy. 1 over negative 4 to the 5th power. Let's go. Okay. Any questions on that example? That was a little tricky. Yes.
So when you flip it like the other
Yep.
fraction, your whole number doesn't change.
No. The base does not change. Very good question. Even though the base was negative 4, right? The only thing that changed was the sign of what? The exponent. Do you guys see that? The exponent changes sign. The base, you don't touch it. Okay? All right. Now, do we have to multiply negative 4 times negative 4 times negative 4 times negative 4 times negative 4?
No.
Why not?
Because it's already
The exponent is higher than 3. Okay? 4 or more, don't touch it. Just leave it. Okay? All right, let's do another one. Let's do C. What do I do in letter C? This one's different. Natalia? That's a Z, actually. Okay, so that's Z to the 4th power, and then it's all being raised to the negative 3rd power. What do you think, Natalia?
You multiply it by negative.
Excellent. So I'm multiplying the negative 3 by the 4. What's negative 3 times 4? So watch this. I get Z to what power? Negative 12. Am I done? Why not? You can't have what? A negative exponent. So Bruce, what do I need to do? To the positive 12. That is our final answer. Sansia, you give me a face.
I'm sorry, I thought it was negative, the Z, but...
Oh, no. So as soon as we move it to the other side, then it becomes positive. It's happy when it's in the other side. We Gucci?
Yes.
Ask me questions, guys. Yes, Sophia. Sure. These are good questions, though, other than that one. Yes, Josh.
Why didn't you just leave the negative from the negative 12 to
No. Great question. Guys, Josh asked, why can't we just move the negative from the 12 in front of the Z? That's when we're multiplying. This is not multiplication. This is exponents. Exponents are a whole different animal, okay? That negative has to stay with the exponent, and that determines that it needs to go in the denominator, okay? Very good question, though, okay? Big no-no. All right, D. What do you notice about D, first and foremost? Gage? It has a negative exponent on the 6. Very good. What else do we notice, Peter? They have the same base. Okay. What else do we notice about them? Are they being multiplied or divided? They're being multiplied. So if they're being multiplied, what do I do with the exponents? Add them. So check this out. This is going to be base of 10, and then 4 plus negative 6, which is negative 2. So we are going to get 10 to the negative 2 power.
And you put it as a fraction.
Good, you put it as a fraction. So it's going to be
1 over 10 to 2.
to the 2nd power. Now, if you leave it like this, you're still going to lose a few points, because what is the exponent? 2. Can you do 10 times 10? And you should. What is it? It's 100. So it's 1 over 100. 10 times 10 is 100, not 20, guys. It's very, very... No, I see it happen all the time, guys. We take this exponent and we're like, oh, it's 2 times 10. It's going to be 20. It happens, okay? Write it down if you made that mistake. Be like, hey, do not multiply these numbers, okay? These are exponents. Make a note for yourself. It's good to make these mistakes now so that we learn from them. Kevin, what's up? You sure? Okay.
It's like 4 or less, we have to.
No, 3 or less, okay? If it's to the 4th power, do I expect you to evaluate it? No, leave it as the 4th, okay? Let's try E. Is this the one you had the question on, Kevin? Okay. What do you think is going to happen now that we have a variable? Josh?
I think you do the same thing, except you just except it would be x to the 9th power minus 9.
Very good. X to the 9th power minus 9. Because they have the same base, and it was x, correct? Now, what is 9 minus 9? So it's x to the 0 power, correct? But x to the 0 is not 0. It's 1. So the answer is 1. Sancia.
I'm confused where you subtracted, but like D you added. But then you subtracted. Never mind. I'm sorry.
Okay, so you bring up a very good point, and I didn't explain this one very well. So let me go back and redo it. Guys, this is actually 9 plus -9. Do you guys agree with that?
Yeah.
Which eventually, this is the same as subtracting these two, right? So it's technically not subtraction. You are correct.
I'm sorry.
Because, no, you're right. And absolutely, you should have brought that up. We're adding these two values together. We only subtract when we're doing what? What operation tells us to subtract? Division. Okay, so she's absolutely right. We needed to add these together. Okay? All right, next problem, F. Now, I want us to be very careful here. What is the base in the numerator and the denominator? No, you're all wrong.
Okay. 1. How could 1?
It's not 1.
5.
It's just 5. Do you remember how I showed you this yesterday? There's no parentheses. So, remember, when there's no parentheses, this exponent is only the exponent of the number next to it, correct? Now watch. This negative is not part of the base, correct? What is any negative divided by a negative? So do you agree that they'll cancel? They're gone. So, we have 5 to the 8th over 5 to the 4th. Write that down. It's 5 to the 8th over 5 to the 4th. What do I do with 5 to the 8th divided by 5 to the 4th? Gage?
You want to bring the 5 to the 4th up so you can make that negative so that the 5/8 doesn't turn into a negative.
So it would be 5 to the 8th
Yeah, subtract
minus 4, right?
Yeah.
So you were saying the same thing, but do you see now why the exponents are negative? Because when they come to the numerator, isn't it being subtracted? Does that kind of click for you guys? So once that exponent moves to the other side of the fraction, it's actually being subtracted. Hence why they're negatives when they're in the wrong spot. Okay? All right, so what's 8 minus 4? So this would be just 5 to the 4th. Do we have to evaluate it? Why not? Its exponent is larger than 3. Okay? Yes, Kevin. Why don't I add them? Oh, yes. Josh. So try G, H, and I all on your own and see how you do. Okay, guys. Fist bumps and high fives for these 3. Go, compare. Okay, let's go. Let's do the first one. What did we do for this one? What do we do? Peter.
Subtracted the 6 and 7.
Very good. So y to 6 minus 7. Okay.
Then you get y to the power of -1.
Uh-huh.
Then you put it in a fraction. And it becomes just 1 over y.
Very good. Now, guys, you can leave it like this. 1 over y to the first. That is also correct. Most of the time, standard notation, especially in the SAT, they're going to take out that 1 and just write it as 1 over y, okay? But if you guys write it on an exam, 1 over y to the first, that is absolutely right. You're going to get full credit, okay? But if you leave it like this, you cannot have that negative exponent, okay? Make sure that you change it. H. Mariana?
So what I did is I did -1 times -2, and then since they're both negative, we can
Good. So what'd you get?
I got 36 because I got 6. As equivalent to, and then 6 times 6
6 times 6 gives me 36. Very good. Very, very good. Any questions on that one? Okay. And then the last one. What happened here? What happened here? Bruce? You just multiply 5 and 12 and you get W to the 60th. Can we evaluate W to the 60th? No. Like, even if we knew what W was, like if it was 7, okay, that would be 7 times itself how many times? 60. And that's going to be a very, very large number, okay? I would never ask you to do that, okay? Yeah, what's up? Huh? An invisible one where? Oh yeah, technically there is a 1 in front of this W. Yes. There's a 1 in front of any number, okay?
Mr. Jurko,
Yes.
is 3 to the 7th power the same as 7 of 7 into the 3rd power?
Say that one more time.
Is 3 to the 7th power the same as 7 into the 3rd power?
Is 3 to the 7th power the same as 7 to the 3rd power?
Yeah.
No. Okay, that's a very good question. Guys, these are not equivalent. Because this first one is saying 3 times 3 times 3 times 3 times 3 times 3 times 3, right? This one is saying 7 times 7 times 7, right? I don't know for a fact, but I would assume this one's much larger, okay, than the other one. But do you see the difference between them? Okay, very good. Any other questions on these guys? Okay, peeps. I have 2 more properties and then we're done, okay? The next property is something called the power of a product property, okay? Natalia, what's up? After Isabella, okay? So, if we have 2 numbers being multiplied as our base, so you guys agree for this example, 3 times 2 is our base, correct? And 5 is our exponent? You can take that exponent and kind of like distribute it to all of the terms in the base. So this would become 3 to the 5th power times 2 to the 5th power. Go ahead, Josh.
So it's like this.
It's very similar to distribution, okay? And how I usually talk about it is distribution, but I wrote a note for you. It is not distribution, okay? We don't actually, technically, we're not supposed to be calling it distribution, okay? Because distribution is when that number's in front of the parentheses. Do you agree? Okay. This one's a little bit different. Then when you are using quotient, so when it's being divided, the same thing applies, okay? So the 5 is the exponent of the 3, and the 5 becomes the exponent of the 2.
So it's more substituting.
More so substitution, right, Josh? But you are actually multiplying this exponent by the exponent of the 3 and the exponent of the 2. But what is the exponent of the 3? It's 1, right? And the exponent of the 2 is 1. So you're just multiplying 5 by 1 and 5 by 1. Okay? Yes, Gabby. So that's a good question. I'm going to write that one down. If it was like 3 over 2 to the 3rd, all raised to the 5th, that's a good question. This would be 3 to the 5th on the numerator, right? Over, what do you think? 2 to the 15th. You take the 5 and you multiply it by the 3. Okay? Good question. All right, let's see some examples, okay? So let's go ahead and check out letter A. Do you see how it's not just 1.5 being raised to the second? It's not just y. It's both of them being raised to the second power. So we take this 2, right? And it becomes the exponent of the 1.5 and the y, okay? So how do I write my answer? Go ahead, Josh.
1.5 to the second power. Would it be plus y to the second
Ah, you would think it would be plus because it's like distribution, right? But it's still multiplication. You're just going to write y to the second power. They're still going to get multiplied. This is why it's a little bit different than distribution. Go ahead, Josh. No, parentheses are gone because we actually use that exponent and we squared both the terms, okay? All right. Now, we do know how to calculate 1.5 squared. How do we calculate that? It's not 3. What do you do when it's 1.5 squared? 1.5 times 1.5. So let's do that on the right. Let's multiply them out. 5 times 5 gives me 25. Bring up the 2. 5 times 1 is 5. Plus 2 is 7, right? Bring down a 0 for a placeholder. 1 times 5 is 5. 1 times 1 is 1. So I'm going to get 5, 12, bring up the 1, 225. Is 1.5 times 1.5, 225? What did I do wrong? Ah, the decimal point. How many spaces to the do I move my decimal? Dos. So move it over 2. It's 2.25 as your answer. Not you, Miguel. So my answer is 2.25 y squared.
Jurko, why'd you bounce the decimal?
Why did I move the decimal? Okay, so anytime you multiply decimals, right? If there's numbers to the right of your decimal, you have to keep track of them so you know how many units to, or you know how many spaces to move your decimal at the end. So you see how it was 0.5 and 0.5? Two numbers to the right of the decimal, 2 spaces over I move my decimal. Okay? Josh, what's up? Because do we know what y is? So would you be able to calculate y times y? Exactly. Okay. B. This is an example of the quotient rule now, guys, okay? So we're going to take A, and A's exponent changes from 1 to what? 3, because 1 times 3 is 3. Now, in the denominator, I want my base to be what? Negative 10. So negative 10 has to go in parentheses. Because if it doesn't, then your base is only going to be 10, okay? And we have to raise that exponent to what? The third power, okay? Can we evaluate negative 10 to the third? What is it? Hold on. Let's evaluate negative 10 to the third first. So it'd be a to the third over negative 10 times negative 10 times negative 10, right? Well, 10 times 10 times 10 is 1,000, right? Does it stay negative or does it change to positive? It's still negative because there's 3 of them, right? So it'd be a cubed over 1,000 negative 1,000. Gage, what was your question?
So the white, could you why did you use the parentheses?
Yeah, so do you see how the negative 10 is part of my denominator? I want my entire denominator to be part of my base because that whole thing is being raised to the third. So I have to put parentheses around the negative 10 so that it's raised to the third, and the whole negative 10 is my base. If you were to write it, Gage, like this, a cubed over negative 10 to the third, the 10 is only your base now. The negative would be outside. That is incorrect because the negative was inside the parentheses to begin with.
Oh, I see.
Okay?
Yeah, I see.
Okay, let's try another one. C. We have 3d over 2 to the 4th power. What do you guys think? Okay, 3 to the 4th, d to the 4th, over 2 to the 4th. Do we have to simplify any of these? Why? It's bigger than 3, so we just circle it. That's our answer. What happened? Oh, you. D. Should we get really, really, really excited that there's a negative exponent? Absolutely. We should get so excited about it, okay? Because it's not anything different than what we're used to. I take this negative 5 and it becomes the exponent of 2x and 3. So do it. It's going to be 2 to the negative 5, x to the negative 5, and over 3 to the negative 5. Hunter, yes. It will eventually, but don't do it right off the bat, okay? So I have a question now. What does an exponent of negative 5 mean? Kind of like it's dividing. In order for us to write our final answer, we cannot have negative exponents, right? How do negative exponents become positive? Flip them, okay? So take these two, move them to the denominator, and take the 5 to the negative 5th and move it where? to the numerator. But when you move it, what happens to the exponent? It changes sign. So this is going to be 3 to the 5th over 2 to the 5th, x to the 5th, and this is my final answer. Santia?
So like you move it because you want the exponent to be positive?
Correct. And anytime you move an exponent from either the numerator to the denominator or the denominator to the numerator, it changes the sign of the exponent. Yes. Yes. Okay, guys, go to the next slide for me really quickly. All I need you to do is answer this question, okay? I want you to pick out the most challenging part of the lesson for you, okay? Answer that question and then turn in these notes to the 6.1 practice assignment.